Hello, my name is Brad Neal. I'm with the University of Indianapolis. I'd like to talk with you about this particular problem, the combustion of a hydrocarbon. This is a pretty classic example of an empirical formula kind of question. In order to answer this, there's some things that we first have to realize. One of the big ones is going to be that we are going to need to realize that we are dealing with a hydrocarbon. A hydrocarbon. A hydrocarbon means that this is a substance that is made up entirely of just carbon and hydrogen. We don't know exactly how much carbon and how much hydrogen is made up in this hydrocarbon. That's the point of this question. We do know that for the combustion of a hydrocarbon, we are only producing two products, carbon dioxide, and we're producing water. So we could say we are producing some amount of carbon dioxide and we're producing some amount of water. Importantly, all of the carbon that is being generated and being turned into carbon dioxide is coming from only our hydrocarbon. Same thing for the hydrogen. So this hydrogen from the starting material is what is going to form the water. This carbon is what is going to form the carbon dioxide. We can use that to our advantage because now we can say, well, we had 8.80 grams of carbon dioxide. That helps us because we know the molar mass of carbon dioxide because we can calculate that from our periodic table. And the molar mass tells us there's 44.01 grams of carbon dioxide for every 1 mole of carbon dioxide. So now when we cancel out units, grams of carbon dioxide cancel. To figure out exactly how much carbon we had in the original sample, we can now say, well, for every 1 mole of carbon that was formed, it formed 1 mole of CO2. So by doing this, we can now see we are left with units of moles of carbon. This will be the carbon that originally started its cycle as this hydrocarbon. So we can do our math and we can say it's 0.199955 moles of carbon. We can do a similar process now for the water. We can say for our water, we had 1.44 grams of water. Now all of the hydrogen that was in our original hydrocarbon went to form water. So we can calculate what the molar mass of water is, and that would be 18.016 grams of water for every 1 mole of water. Now, the ratio between carbon dioxide to carbon was 1:1 because it only takes 1 carbon for every 1 carbon dioxide. Now, for every 1 mole of water that was produced, it required 2 moles of hydrogen from our original material. Now we can go through and we can cancel out units. Grams of hydrogen cancels, and moles of water cancels. This leads us now with 0.1598858 moles of hydrogen. Now, we can't use these numbers as written in our chemical formula. We can't say C 0.19955H 0.159858 because that just kind of looks weird. We want to always use whole number ratios here. So to get everything to a whole number ratio, we're going to take the numbers that we calculated for the moles of hydrogen and the moles of carbon, and we're going to find what the lowest common denominator is by dividing both the moles of carbon and the moles of hydrogen by whatever was the least number of moles we calculated from the previous step. So in this case, hydrogen had the least number of moles. So if we divide then by the moles of hydrogen, by how many moles of hydrogen we calculated, we would say like hydrogen forms in a 1-to-1 ratio. That's fairly self-explanatory. But what if we do the same thing now and we try to figure out what the ratio of carbon is to hydrogen? So we would take the moles of carbon and divide that by the 0.15985 moles of hydrogen. And we would find that we've got a ratio of 1.25 moles of carbon for every 1 mole of hydrogen. So now we could write out a formula of C1.25H1. Now this is a lot closer to actually having whole number ratios, but we're still not there yet. We have this 1.25 here for the carbon. Well, we can get rid of that if we multiply all of our numbers by 4. By doing so, we end up with C5H4. C5H4 is now represented in the lowest common denominator with whole numbers. This would be our final answer for the question of what is the empirical formula given the ratios of, given the masses of products the problem gave us. Thanks. Have a great day.